Now that we know how refraction happens, let's see what would happen if we had the light passing through a glass with a different type of shape. So a different shape, say a triangular shape. So here we had a block, and now we have a triangular shape. And I hope that you can notice the difference here between how a block would have two parallel sides, so two parallel surfaces, and here we have two non-parallel angular surfaces. And let's see what would happen if light passes through this triangular shape. Let's actually call it a prism. So let me just erase this here. This is what we call a prism, triangular prism. And we have the light passing from one side to the other through the glass. So through the glass, and we're gonna have to draw the normal again. And again, we need it to be perpendicular to the surface. So let me try to make it as much perpendicular as possible. So passing through the incident point, perpendicular to the surface. Okay, that's perpendicular actually. Okay, and now let me just draw a dotted line. So dashes here, so that we don't confuse it with the ray. Okay, so what would happen? Now we know that the light, the white light, consists of 7 different light, being Roy GB. So Roy GB, which is Roy R for red, Roy O for orange, Y for yellow, and then G for green, and B blue, I indigo, the color, and lastly violet. So we have these lights, and we know that the lights here, starting from the color violet, is the slowest. So here we have the slowest light, and going from V back all the way to R. So the color red would be the fastest color. Fastest color. Fastest. Let me draw it correctly. Alright, so that's the fastest color. And now we have the color violet. So this color of this white light, white ray, is gonna split. And the way it's gonna split is by bending again towards the normal. So we have the first light bending towards the normal, and then the second light, indigo, again, also bending, but we can see it splitting here. And the reason is the colors here have different speeds. Okay, so the slowest color, being violet, is gonna bend the most towards the normal, and then the second slowest color is gonna bend a little further from the normal. And now we have the color green, also bending, followed by the color blue. No, so we have green here. Okay, I've mistaken the colors. Actually, it's yellow. Again, and then followed by orange. And last, we have red. So the phenomenon here we call, the phenomenon that's happening here we call dispersion. Dispersion. And the word dispersion comes from the verb disperse or spreading. The spreading of lights. So these lights, when you mix them together, and where they are, when they are combined together, they make up the white ray, the white light ray. But then when they are passing through an angular medium, they split up. The light splits. So again, disperse or spreads out. So if we're gonna also draw the second refraction here, we're gonna need to have to draw the normal again, also perpendicular. It's gonna be perpendicular. Let me try to draw this normal. Okay, so how is it gonna bend away from the normal? Remember, because it's bending from, is going from the slower to faster. So it's gonna move away from the normal. And that's how it's gonna look like. Away, and for orange again, also away, yellow, away, green, away from the normal, blue. I'm not drawing the normals for each color, but you typically have to draw it. I hope you can just imagine the normal being over each incident point of its respective color. But anyway, now we end up with a, as you can see, a rainbow. And this is basically how we have a rainbow. This is how rainbows happen, is when we split the components or the constituents of the white color, which are 7 different light colors that are Roy G. Beef: red, orange, yellow, green, blue, indigo, violet. Okay, and this is what we call light dispersion. And that's it for this lesson.